Okay, let's get started. Today we will be covering graphing linear functions. In this particular section, we won't be using any sophisticated techniques. We'll be using those in later sections in this chapter. We'll be doing these problems by plotting points, just as we have previously been doing. I want to remind you what a linear function is. It looks something like this, and we know it's linear because x is to the first power. It's not written, but we know it's an invisible first power, and y is also to the first power. That would be a linear function. There are many, many of these with various slopes and intercepts. And remember that in the last section or so, we started writing y as f of x. So you'll see linear functions written this way. All linear equations are functions, well, with one exception. And we'll talk about that in a few minutes. So f of x is a new representation for y. It's the same thing. So in this particular section, we're going to graph some of these. The first example asks us to graph the linear function f of x is equal to x. And so all we can do is just think of this as y if we'd like to, and make a table with x and y. This is one of those that's so easy it's almost confusing. We get to pick only one value, and the lab instructor said there was a little confusion on this. You get to either pick x or y. In this particular problem, it doesn't matter. I tend to try to pick x, not always, but usually. So for x, I'm going to try a -2, a -1, a 0, a 1, and a 2. Notice that I get to pick only one value. The other values are determined by the equation. So now I must go to the equation and put those in. And so I say y is equal to x, and first x is -2. This is sort of a boring function. Whatever the x is, look, that's what the y is turning out to be also. Okay, let's try the next one. Y is equal to x, and the next x that I'm picking is -1. So see, I'm replacing the x with the value, and that's giving me the same y value out. I'll do one more of these, and then I'm kind of hoping that you get the pattern, and we'll stop at that point. Y is equal to x, and now x is supposed to be 0, the value I picked, and 0 comes out. So whatever I'm putting in is what I'm getting out because x and y are equal in this particular graph. So now we can go to some graph paper and we can plot this graph. Okay, here's my graph paper. Let me draw in the axes on the paper here. You'll want your graph paper for doing these. Keep in mind you can print some off the web if somehow you're stranded without any in this weather. We have -2, -2, -2, -1. I'm looking at the values on my table right beside this. And 0, 0, 1, 1, and 2, 2. And these are just a few of the many, many points on this line, the infinitely many. And we draw the line with our straight edge to keep it nice and neat. Okay, so this is the line f of x equals x, where all the x and y values are equal. Okay, so that was a nice simple example for the first one. We're going to graph several more of these today. Okay, number 2. Keep in mind that if on this video there's anything you want to go back over, you can always stop it and go back over any particular problem. That's the advantage of the video over the real live lecture. 1b, f of x is now equal to -2x plus 1. And again, we tend to think of this as y for graphing purposes, so we'll change that to a y. And we'll make a table. And we will pick the values. And again, I think I'm just going to take -2, -1, 0, 1, and 2 as the x values that I'm going to choose for this function. So now I take this function right here and I go through it with all the different x's that I've chosen and put them in and find the y. So I start with the first one, y is equal to -2, and I'm putting in place of the x the -2 because that's the first one over here, plus 1. Y is equal to negative times negative makes a positive 4 plus 1, y is 5. Okay, so I put a -2 in and I got a 5 out, so I fill the y always depends on the x. If I pick one, I have to calculate the other. All right, and y is equal to -2 times the x. In this case, x is -1 for the second value. And we get y is equal to 2 plus 1. Y is equal to 3. So I go over here, y is now 3. Put a line because we're starting the next one. Each time, go back up to your original equation and plug in the new x. This x is 0. And so y is now equal to 1. All right, let's go over here. Y is equal to -2. The next x is 1. So I get y is equal to -2 plus 1. We get our first negative y. Notice that these are going down. We had 5 minus 2 is 3, minus 2 is 1, minus 2 is... These are going down by 2. That's because the slope is constant on this line, okay? Y is equal to -2, and the last x is +2. Okay, so I have -4 plus 1, y is equal to -3. Barely fit that on there. Okay, so I put a -3, which is what we would have predicted with our observation of the slope there. So now we get the graph out, and we graph. I'll get a new page, I guess. I'll use this one, it will work just fine. Fold it up, and we're going to do a graph of this. And so I begin by placing my axes on my graph paper. And now we plot some points. The ones from the graph here, I go to -2. Remember, the first value tells you the x, left and right, and the second value tells you the y, the up and down. So I go to the left 2 and up 5. All right, to the left 1 and up 3. 0, 1, 1, -1, and 2, -3. Okay, with any luck, that's going to be a straight line. Officially, you only have to plot 2 points to get a line. I would always plot a third, and make sure that you have not messed up. Okay, so we could label this. That would be the best thing to do. Y is equal to, or f of x is equal to, -2x plus 1. Okay, so we've graphed yet another line. Very well, let's move on to the next example. 1c. And this is giving us the function, and I'm going to go ahead and write it as a y instead of f of x, 2x minus 3. Same routine, folks. We make the table, and maybe we'll only do 3 points this time, okay? I'll pick x as -2, 0, and +2, okay? And so we now plug these in. It is likely you might have a hand graphing problem on your test, so be prepared to do this without your calculator. Now let's put a -2 in for the x. 2 times -2 is -4 minus 3. We get y is equal to -7. So we put a -2 in, the y for this line will be -7. All right, go back to this original equation each time, right up at the top, and I'm replacing the x now with a new x value of 0. 0 minus 3 minus 3. Wow, we're pretty in the negatives here. I hope we get a positive. So now I'm finally going to take y equals 2 times the x of +2 minus 3. And my wish finally came true. Y is equal to 1. Okay? And that should be enough points to give us a line. Let's go ahead and graph that. Slide this over. Put my graph grid up and get my axes drawn in. You can really do these pretty quickly and very neatly if you just keep your straight edge handy. Okay. Now, the points that we need for this line are -2, -7. 1, 2, 3, 4, 5, 6, 7. 0, -3. And +2, 1. Notice I spaced these out a little, the x's, when I chose them. That makes it a little more accurate in the graphing, I think. It makes it a little easier. Okay. So this is y equals 2x minus 3. Okay. Now before we move away from this graph, let's talk about a new vocabulary term. And as you remember, this is the y-axis. And so the point down here where the graph crosses the y-axis is called the y-intercept. Okay, so you may want to write in your notes that the y-intercept is where it crosses, the function crosses the y-axis. And if we name that point, you'll notice that the x is always 0. So it will always be 0, something. So also make a note that at the y-intercept, x equals 0. So if we want to define the y-intercept, we would simply go to the table and let x be 0, which we've already done here, okay? I bet you can guess what this is called. The point that it crosses the x-axis is called the x-intercept. Okay. And at the x-intercept, y equals 0. So it's opposite, right? And the next few problems are going to ask us to calculate intercepts and use intercepts to graphing, for graphing. Okay, moving on. We are now ready for number 2. A. Find the intercepts and graph. Then write each question using function notation. Okay. So we have two things that we're asked to do here. We have 4x plus 3y equals 12. Okay. First of all, we're going to find the y-intercept. Let x equals 0 to find the y-intercept. So I can think of making a table of points for this line, and when I put 0 in for the x, that will give me the y-intercept. So I go up to this equation. I don't have to solve it. I can put 0 directly in for the x. Okay, 3y is 12. So divide both sides by 3. Y is 4. So we find out it has an intercept at 0, 4. So let's go ahead and put that on the graph before we find the next intercept. Put my axes in here. All right. This intercept is at 0, so we go 0 in the x direction and 4 in the y direction. And notice that is the intercept. It's the point it crosses the y-axis. That's the y-intercept. So it's looking good so far. And now the other thing they wanted us to do is, second, to find the x-intercept. So let y be 0. All right, so we take the equation at the very top of the page, and we replace the y with 0. Divide both sides by 4. Okay. Well, I should have put this in the table. Y is 0, so I picked the y to be 0. You can only pick one. The one you pick, you use it to calculate, and we calculated that the x that corresponds with that is 3. So now let's place that on the graph at 3, 0. Okay, as I said, 3 points is enough to graph a line, and I think we've done this nicely, so we can just go right ahead and draw the line. Okay, there's a graph of the line that they gave us. Now they asked us also to write the equation using function notation. In order to do that, we're going to have to take that equation and solve it for y, and then change y to f of x, okay, using our function notation. So I'm going to recopy this equation at the top. Okay, so part 3 is to write with function notation. Okay, so I'm solving for y. That's the goal. So I begin by leaving the 3y over here, and I bring the x over, subtracting 4x. Subtract 4x from both sides and show that step if it's helpful for you. Now divide everything by 3. Divide it all by 3. 3 divided by 3 gives me y. We have negative 4 divided by 3, and a 12 divided by 3, which we should rewrite, obviously. 12 divided by 3 is 4. Okay, so we have now solved for y, and it's easy at this point to put this with function notation. We change the y to f of x. All right. Looks good. So we did everything they asked us to on number 2A. Let's move to 2B now. 2B. Excuse me. Same thing. Find the intercepts and graph it and write it with function notation. All right, so they have given us y equals negative 4x. And we need to find the intercepts. So here's my table. And to get the y-intercept, let x be 0. All right. So we take this equation and we put 0 in for x. When we do that, y equals 0. So I put a 0 in for x, and y turned out to be 0. Let's think a second what the x-intercept would be. If we wanted the x-intercept, we would let y be 0. But we know when y is 0, what's x? We already found it, right? So the x and y intercept are the same. It intercepts at the origin in this particular graph. So that isn't going to give us enough to graph the line. We'll need another point or two. I think I will let x be negative 2 and positive 2. Because with only 1 point, we can't graph the line. Let's go ahead and get it started, and you'll see what I'm talking about. Okay, there's the y-axis. Here's the x-axis. And it intercepts the y-axis and the x-axis right there at the origin. Well, that doesn't give us enough to draw a line. So I'm going to calculate a couple more values using my function here. to do my graph. So I'm going to put a -2 in for x, and I'm not going to show all the work now. -4 times -2 is +8. Now I'm going to put a +2 in. -4 times +2 gives me -8. So it also goes through -2, 8, and to -8. Okay, so I'm going to put those on my graph. -2, 1, 2, 3, 4, 5, 6, 7, 8. Good, I double checked it. And +2, 1, 2, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8. Good. We've got 3 points, so it'll be easy to graph this line. Okay. And we could label it. But let's go ahead and do the next part of this problem, and that is to write this using function notation. This is easier because it already is solved for y. We simply, to write it in function notation, we change the y to f of x, or g of x, whatever you want. So I replace the y with the f of x. Okay, that was the third thing they asked us to do. Good. All right, we have one more example with the intercepts, 2c. And this is the function x minus y equals 4. All right, and they ask us to find the intercept. So I'm going to begin by getting the y-intercept, and I'm going to let x equals 0 to do that. So I put a 0 in, multiply both sides by a -1. Negative times negative makes this positive. Positive times negative makes it negative, okay? So we make a table, and I put 0 in for x, and when I did, y correspondingly was -4. All right, now I'm going to get the x-intercept. And to do that, I let y be 0. So I put a 0 in for y. And when I do that, x is 4. So I put a 0 in for y, and x is 4. So let's go ahead and graph that. Zero, -4, and that's the intercept of the y-axis, the y-intercept, and +4, 0, that's the x-intercept, the intercept of the x-axis. And now we have 2 points. We can draw the line. Looks good. And the final thing on this problem is to write it in function notation. So I'm going to go back to my original equation up here, and I'm going to solve it for y. So I have x minus y equals 4. You have 2 choices here. You can move the y over to make it positive, which is what I'm going to do, or you can move the x over and multiply by -1. Oh, let's just move the x over. Why not? I think that's what most of you would do. Let's subtract x on both sides. So we have -y equals -x plus 4. Notice that in the lines, we usually put the x first and then constant, the number last, okay? So now I'm going to multiply everything by -1 because I don't want negative y, I want positive y. So y is equal to negative times this, negative times that. So it switches the sign of everything. And now finally, once we have it in terms of y, we can write it with function notation. F of x equals x minus 4. I sort of ran out of room, but it works. All right, we're nearing the end. The next problem, number 3, which has 3 parts, is to do the special cases, those horizontal and vertical lines. Okay, grab another piece of paper. Number 3, graph x equals to -5. All right, when we make a table on this, we are restricted somewhat because x is -5. That is the only thing x can be. Now, what about y? Y can be anything, okay? But x has to be -5. So you can put any of your favorite numbers in over here. I chose 0, 1, and -2. All right, I'm going to do a quick, not so fancy graph by hand. 1, 2, 3, 4, 5. Mark it off in 5. Okay, 0, -5 is right here. And, oh, sorry, I did that backwards. We have to go -5, 0. Okay, let's use a different color now. Correct that. We go -5, 0 right there. And then we go -5 again, 1. And -5, -2. Okay? So always x is -5. So we will be getting, regardless of what points you pick, they are -5 something. We will be getting a vertical line. Vertical lines always say x equals something. And this one is x equals -5. Okay? That's a special case. And this is not a function because for each x, for -5, you can see that we have more than one y. So this is not a function. Almost all the lines that we work with will be, but the vertical one is not. Okay, let's go to B. And they want us to graph the vertical or horizontal line y equals -2. So when we make the table here, what's determined is that y has to be -2. X can be anything. I chose a couple of numbers. And now we will make the graph. So I'm going to go to 3 in each direction since that's the largest number I chose. And we want 0, -2 right here. And 3, -2. I'm going to go use another color here. I kind of semi-missed that point, but oh well. I should have used fancy graph paper, I guess. So this is the line where y is always -2. For every point on this line, y is -2. This is a horizontal line. And we'll be talking about slopes soon. You can see that this would have slope 0 because it's flat. It doesn't go up or down at all. It has only an intercept on the y-axis, and all horizontal lines are written y equals something. In this case, y equals -2. Okay. And our last example in this section, we will be doing 2 sections today, but I will record the next section separately. 3c x minus 4 equals 0. And this one you might not immediately recognize as horizontal or vertical, but it only has an x. So if we wrote this as x equals, we add 4 on both sides, x equals 4, then we would pretty quickly know. If x is 4, y can be anything. X is 4, x is 4, 0, and 4, negative 2, 4 something, 4 something. It's going to be a vertical line. Put your arrows on it so that we know it's not the axes. And we'll go ahead and label it x equals 4 everywhere on this line. We have another vertical line. Okay. All right, you should be ready to do some exercises and do the MyMathLab homework on this section at this point. Good luck, and we'll see you in just a few minutes for section 3.4.